Recording. Good. Recording in progress. So we go back to the screen that I had shared yesterday. Now in the host computer. Back there. I share. I believe my screen is now showing up on your side. Yes. We were trying to define some of the terminologies that we shall be using in this topic. We'll not go through the preliminaries for now. I want to first go to the definition of some of the very important terms that we shall be using quite often in this particular topic. We started looking at the terminology bits, and bits, as you can see there, we are saying this refers to a binary digit. This refers to a binary digit, which can either be a 0 and a 1. So the thing that we have said that the computer knows only two states, on or off, which are represented by 1 or a 0, respectively. Those form our two digits, binary digits. So the word bit is actually an acronym derived from BI for binary, from the word binary, and then the very last T that we have in the word digits, digit. Okay, so bit. And it is actually the very smallest, the smallest unit that we can use to represent data in a computer. The very small, the smallest element that can be used to represent data in the computer is called a binary digit. Now, the second terminology is called a byte, which is simply a group of 8 bits. Soon, we are going to learn, for me to represent letter A in the computer, I require to use what we call a byte. A byte is a group of 8 bits. A byte is a group of 8 bits. And therefore, in other words, this is the combination, it's or rather, let me say like this. We need a group of 8 bits to represent what we call a single character. So character nayo ni kitu gani? When I type letter A in the computer, it is a character. Therefore, a modern computer will require a group of 8 bits to be able to store my letter A. To me, I know what? To me, I know letter A. But to the computer, remember again, the computer is a fool. It does not know anything else apart from 1 and a 0. So the A that I type must be converted to become representable in the machine language. When I talk about the machine language, it is what the computer can be able to understand. Okay? So the computer understands only a language of ones and zeros. Therefore, when you type A, when you type Q, when you type a question mark, whenever you type something, it has to be converted into a series of binary digits, right? So to represent a single character, you need a byte. You need a byte. And therefore, a word like computer, COMPUTER, which has 8 letters to us, it will require how many bits? It will require 8 times 8 bits, because each character is taking a byte, and a byte is equal to 8 bits. Therefore, the word computer with 8 letters of the alphabet requires 8 times 8 for it to be stored. Therefore, it requires 64 bits. I gave an assignment and I can give you the results, and I can tell you the results are quite terrible. So that's why we have to do this recap. Okay. Now, the next thing is a term that we call nibble. Nibble is simply half a byte. It's a group of 4 bits. It's a group of 4 bits. A group of 4 bits is called a nibble. Then we have got a word. A word. So forget about the word that you know, like the word, the word computer is a word, or any other word that you can write. But forget about that one for now. And we define the word that the term word like this. It consists one or more bytes and is the largest amount of memory that the computer can handle. There we can add at a given time. The largest amount of memory that the computer can handle at a given time. Now, this is not very clear. Let me combine it with word length. Word length, which is the next term that we have down there. The number of bits in each word of a computer. All right? I first stop sharing from my host computer. I go back to my companion computer here, my whiteboard, and I show you what this means by illustration. Okay, so there I am. Now, I have on the left side, I have something that I have written there. Okay. Nimeandika nini? Nikki, unmute and tell me what have I written there in that small box. Nikki, unmute. What do you have on the left side? Rispa, unmute. Tell me what you can see on your left side.
CPU.
Sorry, Rispa, again.
CPU.
Beautiful. Now we are together. So remember to mute, and Gloria also remember to mute. Okay, now this is a scenario where we need to have the random access memory communicate to the CPU. So on the left side, I have the CPU. Every computer, even the phone that you are holding, has got the two components. It has a CPU, it has got a random access memory. Okay. Now, how would communication take place between the CPU and the RAM? It's like this. There has to be wires connecting the CPU to the random access memory. There has to be wires connecting the CPU to the random access memory. Okay, now in this illustration that I'm trying to do, I have already done 1, 2, 3, 4, 5 wires. So in these 5 wires, what do we transmit within wires? We transmit electrical pulses. These electrical pulses can either be charges, which can either be on. This wire can be at times on. There can be another one which is off. On. Another one might be on. Another one might be off. I'm just giving an illustration, an example. Gloria, kindly remember to unmute. Right. So in this case, what can be transmitted between...
Aku nifanya. Ano to so terrible. No one did that.
Now, Gloria, we can hear that. We can hear that. We can hear that. We can hear you very loud and clear. So we shall mute you from our end, Gloria. But always remember to mute yourself whenever we are in such meetings. So we want to mute everybody. Now you see it's taking more time. But remember always to mute yourself. Now, in this case, in my illustration here, what do we have in the first line? That one is what we are calling a 1. Why? Because the wire is on. Then in the second wire, what can we have there? Somebody type in the chat box. Type what we should have in the second wire. Just type what we should have in the. Very good. 0. The third wire. Somebody. The third wire. The third wire. The third wire now. Lucy, are you talking about the third wire now? Sheldon, are you talking? Yes. Sharon. So we have a 1. And then, of course, there will be another 1. And then for the fifth wire, we shall have a 0. Now, a word. A word. We have said a word is the maximum amount of data that can be held in a memory at one given time. I want to give this illustration so that we exclude the word memory now. In my illustration that I am drawing here, I'm indicating that we need to have a bus. Remember what buses are in the topic of Form 1. There is a bus which links the CPU to the random access memory. In this case, it is a 5-wire bus. It's a 5-wire bus. Therefore, how much can this wire contain at a given time? It can only have 5 bits being transmitted at a given time. It can only transmit 5 bits at a given time. It cannot be able to accommodate much more than 5 bits. Why? Because the channel has got 5 wires. It has got 5 wires. Now, back to our example now. I stopped sharing from my companion. Yes, I stopped sharing from my companion. People are still calling. Mute the phone there. So I have stopped sharing from my companion. I go back to my host computer. Keep checking these things from my host now. From my host computer, I'm sharing again. So that now we demystify the issue of a word and the issue of a word length. The issue of a word and the issue of a word length. Okay, beautiful. So what are we saying? A word consists of 1 or more bytes and is the large amount of memory that the computer can be able to handle. Or in other words, you can look at it now, instead of us using the word memory in the definition there, we can also say it's the largest amount of bits that the computer can be able to handle at a given time. For us who are using computers, I don't know how many, by a show of hand, so many they are using. How many are using computers? I don't know how many are using computers. One of them is myself, by a show of hand. Inua mkono kama wewe unatumia computer kama mimi. So all of you are using phones? Okay, no problem, no problem. But however, if you are using a computer, you can always, so Jackie is using a computer, and probably there are some others who are using a computer. The computers we are using, if they are using something like Windows 10, Windows 11, Tracy is also using a computer. Whatever the version of Windows that you are running, there is a way that you can be able to check somewhere, and you can be able to say that this computer is a 64-bit computer. What is that? 64-bit computer. That is the word length. So look at the last definition that we have there. Word length, the number of bits that in each word of a computer. The number of bits in each word of a computer. So a 64-bit computer, it means that the channels that interlink devices or interior components like the CPU and the RAM, they have 64 wires. Therefore, how many bits can be able to be transmitted at a go? 64 bits. So in other words, the higher the number of bits, right, the larger the word length is equal to the faster that computer will be. Are you getting that? That again, the larger the word length, the faster that computer will be. Why? Because it can be able to transmit as many bits as possible simultaneously. You know, we are transmitting some data from RAM to CPU. How many bytes can be transmitted in a 64-bit computer? Is 64 over 8, meaning we are able to transmit 8 bytes simultaneously, which is equal to 8 characters at a go. Kwa hivyo, kuna kompyuta ingine ya 32 bits. 32-bit word length, it would mean how many characters can we be able to transmit at a go? Somebody do that calculation. A 32-bit computer, how many bytes or how many characters can it be able to transmit at a go? Chat box again. Waiting. Waiting. 4. Yes, Titan. Stacy, 4. Sheila, 4. Tracy, 4. Everybody saying 4. Correct. We are very much together. Very much together. So get acquainted to these terminologies because you shall be requiring to of course, use them quite often, especially in this particular topic. Now, I will not go into the details of how, this is an illustration of how it is in your notes, the notes that you have shared on the WhatsApp group. You'll find these notes. It's how does a CD work? And do we need this one anyway today? I don't know, because CDs are becoming phased out. So we got to this level of asking ourselves how the computer, the types of data representation that the computer can have. And I introduced you yesterday to what we call the decimal number system. Deci, we said, is equal to 10. Deci is equal to 10. And therefore, the number of digits that we use in decimal are the commonly known numbers. The numbers 0, 1, 2, 3, ukizihesabu zote, ukiziandika hapo kwa notebook yako, utaona zote zinakuanga 10. Zote zinakuanga gapi? 10. Now, I go to my companion computer here so that I try to illustrate that. I don't want to lose anybody. Remember, just be telling our colleagues who are hanging out there that we may not be able to repeat this again, and therefore they are losing quite much when they don't join our lessons. And again, they are not telling us the challenges that they are facing. Okay, now on that screen, we have the decimal number system. I'm avoiding to finish decimal number system. And I just want now to talk about why decimal. It is called the decimal number because all these digits, ukihesabu hizo digits from 0, 1, 2, 3, 4, 5, all the way to 9, you get these are equal to how many digits? They are 10 digits. So because that the number system called decimal has got 10 digits, and following that, we are going to be discussing many other number systems, right? We are going to be discussing many other number systems. Then it will mean whenever I want to write a number, say like number 8, in the decimal number system, I need to qualify it. Kusema, this is a decimal number system. Kwa hivyo, to qualify it, what have I done? I have added a base. I have added a base. This base yesterday, we found that this can be, it can also be called a radix. It can be called a base. It can also be called a radix. I believe we are together that far. Even Laquisha, who is unmuting quite often. Laquisha, mute yourself once again so that we are able to move on very well together. We don't want to lose anybody behind. Very good, Laquisha. So, why do we add that base? Why is it important? Again, it is because we are going to be dealing with many other number systems. We are going to be dealing with about 4. And because some of these may also have a digit 8, how will I know that this is an 8 in the decimal number system and not in any other possible system? Okay, so we have the radix. Then some other terminologies that we were introducing yesterday. We can see Lina is busy scribbling something on our screen instead of scribbling things on her notebook. There are some other things that we were introducing yesterday, like the number. I want to have a number here, a number called, I want to have a number 3, 5, 6, 2. A number like that, to the base of 10, to the base of 10. Now, what makes this number to have the value that we normally call 3,562? We also learned that every digit that we have here has got what we refer to as a positional value. In ile huwa mnaita place value. Now, I have put my arrow underneath 2. What is the place value of the number 2? Somebody unmute quickly, shout it out. The place value of the number 2?
Once.
Beautiful. Thank you very much. So this is called ones. The next one, which is a 6. Somebody shout it out.
Tens.
Tens. Good. The next one, shout it out.
100.
Hundreds. Next one.
1,000.
Thousand. Beautiful. I can tell you, you are beautiful. Nyinyi ni wale wazuri. Nyinyi ni wale wazuri. Kwani nimeguza wapi na mimi? Okay. Keep them. I have messed up. I have shut down my screen. Let me share again. I interfered with my co-host computer here. Share it. Share what we have there. Have I shared the right thing? No. I have not shared my correct window.
Uchote maji kwa tap.
Wacha aende akachota maji hapo kwa tap. alafu akuje
Aye.
arudi. Tunakusikia tu, usipo mute utakuwa umetupatia mambo ya kwenu mengi sana. All right, I'm looking at, oh, I interfered with the order of my windows. Sorry for that. Okay, so these are previous things that we had gone through. We are there. Now, why is this important? Why is this important? Now, let's consider the case of the number 3, the case of this number 3 there, and the case of the number 6 there. Listen very carefully to this question and give me an answer, which of course you must think. The number 3 I have there and the number 6 that I have there, the circled numbers, which one is bigger than the other? Which one is bigger than the other? Unmute and carefully give us the answer. Jackie says 3 is bigger. Jackie, unmute. Kindly unmute Jackie. Jackie, unmute. Give us a reason why.
Because it's in the thousands place value.
So in other words, Jackie, you are telling us that because of the positional value of the number 3, which is in the place called thousands, that makes it to have a higher value than the 6. Very correct. Now, an exercise that we shall be doing quite often is like this. Whenever we are given the number system that we are dealing with, and having discovered how many digits that it has, and the number of digits determine the base of that particular number system that we are referring to, then there is a way that we can derive any number. Like, how do we prove that the 3 should be called is in the thousands position? Is in the thousands position. This is what I want us to do now. 3. The other digit now was who? Let me imagine that I had a 5 here, and then I had a 6, and then I had a 2. Okay. I have my 4 digits there. Now, let's try to see how we shall be deriving a number. This 2 to get its positional value, and this 6 to get its positional value, we need to understand this. 1, we are using a number system called base 10 system. Base 10 system. The decimal number system is called base 10. So every number that I have here is in base 10, is in base 10. All of them are in base 10. But from the right side where we have the number 2, I now assign ascending orders of powers. Like now, the first 10 here, I'm going to give it a power of 0. The second one, I'm going to give it a power of 1. The third one, I'm going to give it a power of 2. The other one, I'm going to give it a power of 3. Okay? Now, you must be having a calculator close to you. But even if you do not have, this is a simple arithmetic. So this is what I want you to do. 3 times 10 to the power of 3 equals, somebody should be getting me the answer for that. Uandike hapo 3 times 10 to power 3, sijui power 3 utatuandikaje. Mwingine atufanyie 5 times 10 to the power of 2 is equal to 6 times 10 to the power of 1 is equal to, and kwani mmemaliza kabla mimi niandike? Naorodhesha hapa. 10 to power 0 is equal to. Cynthia says that 3 times 10 to the power of 3 is equal to 3,000. Very good. Sasa huyu ananiadikia 500 ni ya wapi? 500. 610 ya wapi? D-Lane. Nancy ndio anafanya ya kwanza. Nancy tushapita huko. Rispa tushapita huko. Nani anafanya ya pili? Nani anafanya ya pili? Ya pili. ya pili 2. 500 from Jackie, 500 from Jackie. And the third one now, the third one, the third one, the third one, the third one, 60. Kezia, Masi, wewe, kutuaibisha hapa. Unaandika nini? Yeah, the third one, 60. Very good. Ninaona mathematicians tuko now in the house. Very good. The last one, the last one. Nishajaziwa hapo namna hiyo ya kwamba ni 2, lakini unaandika wapi wewe? Unaiandika kando kwa nini? Because I then want us to do the addition. So this now is what we can use as a proof that the 3 that we have is in the thousands position. The 5 that I have is in the hundreds position. The 6 that I have is in the hundreds position. And the 2 that I have is in the ones position. Why? Ya kwanza, the 2 has generated only a single digit, 1 digit. Nayo hii ingine, it is producing 2 digits, which we normally refer to them as tens. 500, hundreds, and then thousands, tens of thousands, and the like. Okay, so that's basic mathematics, my friends. That's basic mathematics. And when you add this now, huyu jamaa amefanya vibaya, ametuandikia mahali pabaya. So I do my addition, and drop the 2 there, I drop the 6 there, I drop the 5, I drop the 3. That is how we can derive the number 3562, considering the position values. Considering the positional values. Very important, my dear girls, is this part here. This part. You must be able to understand that every number that you have will be given its value considering its positional value, or its positional, its place value. Ukielewa hivyo, hii mambo ya number systems yatakuwa rahisi sana kuelewa. And therefore, now let me take you to what we did not manage doing yesterday. Yesterday, we were not able to handle. We were not able to handle any other system apart from the decimal number system. So it's like we were doing a recap. Tutan cannot hear. Tutan cannot hear. Who else cannot hear by a show of hand? Anybody who cannot hear me? Tutan uko peke yako. Angalia network ya pande ya kwenu. Na ninajua wengi wenu mko na network mzuri sana na huko manyumbani. Huko kwenu network hata sio kama huko kwangu. Huko kwangu ni lazima nipandishe simu yangu kwa miti kule juu ili ikaweza kunishikia network. So I believe everybody is getting us loud and clear. Tutan, check your network. Now, let's go quickly to the binary number system. Binary number system. Binary number system. Binary number system. Are we together? Hii nayo ndio tutaangalia kushughulikia saa hii. In how many minutes? How many minutes are remaining for our meeting to end? I'm in a screen which I cannot be able to see what time it is.
7.
We have how many minutes?
7.
7 minutes to go. Very good. Okay. So we shall utilize these 7 minutes to the best possible. Binary. Bi means 2. Is that true? Binary, I was told by my teacher that bi means 2. Therefore, in this case, we are looking at a 2-digit number system. 2-digit number system. We can also call this system a base 2 number, a base 2 number system. Base 2 number system. Nyinyi muandike vizuri, muandike vitu zenye zitasomeka huko. A base 2 number system. Why? It has 2 digits. So which are these 2 digits? They must be known. The known digits in the binary number system are a 0 and a 1. We have only 2 digits in the binary number system, and they are known to be a 0 and a 1. These numbers, we normally qualify them by adding a base. Remember, we are saying this quite often now, that we normally need to qualify any number. Because of the system that it might be in, you must always remember to qualify it. Kwa hivyo, nikiandika a number like 101, ni lazima hapa chini ninakumbuka kuongeza what is the base of that particular number. 101 now, this is not equal to 101 in the. Umeelewa hivyo? Nani atatusomea ya kwamba hiyo nani atatueleza hivyo ni kumaanisha aje? 101 to base 2 is not equal to 101 to base 10. Nani atatueleza hivyo nimesema ni kumaanisha aje? Somebody unmute. Haraka haraka tusonge hivyo. Shida boy, kwani utakaa ukinyamaza tu hapo na hausemi chochote? Ama Ashley? Ama nani? Jacinta alituombea. Morugi? Angeline? Somebody unmute. Tell me what you understand by that. Just unmute yourself. Anybody? Explain what this statement means. That statement on the whiteboard, that 101 of base 2 is not equal to 101 to base 10.
I think that means
yes.
101 binary number is not equal to 101 decimal number.
Very good. Very good. Tuanga makofi ama kidore juu. Yes. Mwingine anapiga makofi. React. Go to react. Thumbs up. Very good. That's a very well framed statement that 101 in binary number, in other words, in base 2 is not equal to 101 to base 10. Base 10, remember, is the decimal number. Hazitoshani, hata kama hizi zinaonekana zimefanana, they are not the same. Okay? Therefore, I remind you, this is the importance of us adding the base. Adding the base. The importance of us qualifying every number that we shall be putting down is because of 101 in the binary is not equal to the 101 in decimal. Okay. Now we move on now to the next stage where I said we must also learn as much as possible knowing the meaning and the importance of the place values, the positional values. Let's go to another slide here and I write one number in binary. Niandike number hapa ya binary. Niandike mahali kama hapa hivi. Niandike hivi 1 0 1 0 1. Hiyo ni namba ndefu kwa binary. Okay? Now, the number system in question, the number system that we are dealing with is called binary. And therefore, the base of the binary number system is 2. 2. Every digit here is in the binary number system. But what about the positional values? What about the positional values of each digit? Just like the decimal number system, we start assigning place values from 0 kuanzia pande gani yako ya right. Hapo nimeandika ka 0, hako ni ka 0, hako ni ka 0. Alafu 1, alafu 2, alafu 3, alafu 4, alafu hata ukifunga macho unasonga hivyo mbele towards your left, unaziandika hivyo. Okay. Now, let's derive the actual value so that again we can learn what is the positional value or what are the positional names that we use in binary. Okay, without first multiplying the digit that we have in the upper side with the 2 to power 4 and so on, let me have somebody reacting to this. What is 2 to power 4? 2 to power 4. Shout it out. 2 to power 4. 2 to power
16.
Anaogopa. Hapa hakuna vita. Unajua kwetu na kwenu ni mbali. Kwa hivyo huku hakuwezi kukawa na vita. So this place where we have 2 to power 4, mahali hapa panaitangwa 16. Panaitwa aje? 16. 2 to power 3 is equal to what? Somebody? We are waiting. 8. So the position of value here nayo inaitagwa aje? 8. 2 to power 2.
4.
Kwa hivyo mahali hapa panaitwa aje? Fours. Unaona? Alafu mahali hapa kuna 2 to power 1.
Twos.
Naona? Twos. Alafu mahali kuna 2 to power 0.
Ones.
Very good. Beautiful. Tutapaita ones. Right? So you can see now the position of values that we have. By I don't want you to do this mathematic, but I can do them for you. Like now, for me to derive this one, the one that we have there, I'm going to multiply 1 times 2 to power 0, giving me a 1. Hiyo ni mathematics ya kawaida. 1 times 2 to power 0 gives me a 1. Then let me also get this. 0 times 2 to power 1 gives me a what? Any number multiplied by any, a 0 multiplied by any number will always give you a 0. Kwa hivyo hapo usijiumiza kichwa bure. Na kadhalika. Sitaki kufanya hizo zingine, maana hizo tutazikujia baadaye. Tunarudi hako kahesabu, unaona nikiavoid saa hii, tutarudi kwa hako kahesabu. Now, what do we need to understand so far? The binary number system only has 2 digits. Chapa hapo kwa chat box. The 2 digits in the binary number system. Andika hapo. Umeandika? Amuandiki? The only 2 digits that are possible are beautiful. Can see Stacy. Nice. You are the best. Titan, you are nice. Very good. Yes, Nikki. Good. Beautiful. Even Samsung is also present and is also writing 0 and 1. Beautiful. Write any place value that you know in binary. Write any place value that you know in binary. Again in chat box. Any place value, any place value that you know in binary. Andika hapo haraka. Naiona 4s, 2s. Andika 5s. I wish you were here. 3s. I wish you were here. 1s correct. 1s, 8s correct. 1s, 8s, 2s. Sasa hawa wenye wameandika 3s, I wish I can come to your home, nikukujie huko. These umepata wapi wewe? Na tumesema the only possible place values, how do you know the place values in a given number system? Like this. We are talking about the binary number system, which is using base 2. Why? Because it only has 2 digits, right? Now, how do you know the positional values of the base 2? Unaanza kuziorodhesha hivi, 2 to power 0. Kwa calculator yako unapata majibu 2 to power 1. Kwa calculator yako unapata majibu 2 to power 2. Kwa calculator yako unapata majibu 2 to power 3. Kwa calculator unafanya majibu 2 to power 4, 2 to power 5, 2 to power 6, 2 to power 6. Yes, shout out what is 2 to power 6. Sema haraka tufuge mkutano, twende tukaangalia
64.
64. Kwa hivyo maana hapa tumepata 64, the positional value that we generate by 2 to power 6. You know, the number which is in the what position? The number which is in 1, 2, 3, 4, 5, 6, 7. The number which will appear in the 7th position from your right side kwenda left, we shall be saying that it is in the 64's position. Hiyo ingine yenye imefuata the 6th position, it is generated on the position where we have 32. You know, 2 to power 5 is equal to 32, and therefore a number which appears there, we call it 32's. Kwa hivyo wale ambao walituandikia 5s na mwingine akatuandikia 3s, si mnaona hata nyinyi mko na kaudu, all right? Hata nyinyi mko na jambo. Anyway, I wish that we stop there for now, and I want to respond very fast to any reaction that you might be having, anything that you might be having regarding what we have so far said. Just raise your hand wherever you are and give us your response. Anybody, you are free now to do that. Nani. So everybody now is comfortable. Sheila, I can see how you have been so careful. Umetulia hapo vizuri. I'm happy to see you. Just quietly listening. So Sheila Wamboi. Okay. Yes, Samsung we can tunakuona mahali ulipo, uliachiwa kazi kubwa kabisa. Kindly recap and tell us what you have understood about decimal numbers. Kindly, Samsung, Galaxy, usiogope, ongea tu, even with the mic, even with the video, we are okay. Tunaona kazi umeachwa, ulide kazi nzuri kabisa. Yes, tell us what you have understood today in today's lesson about decimal numbers. Huyu ni Barbara. Kwani tena anajificha? Okay, Ejelin, just unmute yourself. If you also want us to see your face, no problem. You can unmute video. You can unmute even the sound. Do a recap of what we have said about the decimal number system to Malize. Why are people afraid to contribute? Hata kama utaongea na mother tongue, si uko kwenu. Ajeline, or are you talking? You have unmuted and I cannot hear you. I cannot hear any sound from Ageline. I wonder whether the mic is working well. Shaira, Wamboi, kindly unmute. Tell us what you have understood about decimal number systems. Just a quick recap, very fast one. Tuambie chochote umeelewa.
They range from 0 to 9.
These are numbers which range from 0 to 9. Somebody else remind us what if I say that the decimal number is also called base 10. Sharon, this is Sharon. Sharon without Wangari. Sharon, just tell us, what does that mean? That decimal numbers can also be called base 10 numbers. What does that mean? Or why do we get the name base 10?
They have 10 digits.
There are 10 digits in the decimal number system, okay? And then you have remembered the issue of the base, that to qualify one number from another, we shall always be adding a subscript of 10 in the decimal, 2 in the binary, right? Another one now to Nikki, kuna wakati nilikuuliza swali na haukujibu wewe. Yes, Nikki, now unmute and tell me what are the digits that we have in the binary number system? What are the digits that we have in the binary number system? Just name the digits of the binary number system. Nikki, hiyo ni yako. Okay, Ageline, all right, it's okay. Just be checking what might be the problem about the mic. Honestly, we didn't hear a voice from you. Nikki is also afraid to unmute. Alice Lucy, what are the digits that we have in the binary number system? Again, Alice Lucy, hatuja kusikia. Alice, you had unmuted quite well, lakini sasa tena hatujui umeguza wapi, hata hatukuoni. Lane, tell us. Yes, Sharon. Sharon ako na mkono juu. Tell us. Sharon. There are people who are not able to unmute. Yes, Sharon, now you have unmuted. Talk.
0 and 1.
Beautiful. Rispa, name 3 possible positional values in the binary number system.
Most of these gray market operations are being sold off.
Name 3 possible positional values in the binary number system. False. Choose.
8.
Very good. Thank you, friends, because of coming in for the lesson. Keep telling the others that we are still learning. We are moving on. And the things that we are learning, I think we may not repeat them again. So they are missing. But now that we have managed to do a recording, I'll be posting a link of where we can always access whatever we have covered, probably on our WhatsApp wall. I also found there are some who are having that challenge. They are not on our WhatsApp wall. And therefore, they are missing so much valuable communication that we are making on the wall there about the links to the classes and links to the exams that we shall be doing quite often. Even after this lesson, probably after 3 hours thereabout, check a link that I will post on the WhatsApp wall for a review or an exercise which will help us review what we have covered so far. You can see today we have taken much time to recap what we had yesterday, and I think we shall not always be doing that. We may need to progress. So make sure that you advise the friends who are not present to always make efforts to join in the sessions so that we may not have a time to keep on repeating whatever we have already talked about. Parents wengine bado wamewaangusha, muwakumbushe watume ka kitu pande hii. Najua hii kitu tulilipia jana ili iweze kuwa ya manufaa yetu. So kindly, the parents who have not yet complied, remind them to do so. 150, send to that my number. So I'm happy again to see all of you. I wish you God's blessings even at home. Muwe watoto wazuri huko, watiifu, na muendelee kuwa watu wanaofanya bidii kwa kazi zao zote. Now, do we have a volunteer to wind up our meeting, or anybody with a final reaction? Not necessarily based on whatever we have said today. Any question, even outside what we have covered today? Any issue? Okay, kama hakuna, tufungiwe meeting na mmoja wenu. A volunteer, kindly, just unmute and say a short word of prayer as we wind up. Anybody, feel free to do that. Anybody, feel free. Waiting. Yes, Winnie. Winnie, carry on. Winnie, you had unmuted well. Only that we did not hear you.
Okay. Let us close our eyes for a word of prayer. For the Lord, and before our presence in your praise, Jehovah, we do say thank you for that section, King of Glory, that you have been with us, my Father, King of Glory. May you guide us, may you help us, my Father, so that when we meet tomorrow, we shall be well. Amen.
Amina. So thank you very much. Situonaneni kesho, inshallah. Mungu akitujalia, muwe na wakati mwema. Stay safe and blessed till we meet again.
Bye.
Bye.
See you.
Bye.
Bye.
Naweza mwambia ndo kakufia. Namwambia ndo kakufia na huko. Hey Magda.
Acha mambo mingi.
Niwe Magda.
Nani anatuwekea nyimbo?
Sema hiyo wimbo.
Oh, bibi.
Wewe.
Wewe sio mimi, sisi tuzangi nyimbo kaa hizo. Wewe Magda.
Una mdomo mingi.
Guys. Wacha tuongea utakiwa.
Sharon.
Yes.
umesalimia. Labda. Eh?